Welcome to your first hands-on experiment using your kit. And you'll have to dig through your kit, and one of the things you'll want to do is make sure you kind of take note of how everything's laid out, maybe take a picture, because one of the things I found about that kit, trying to get everything back to exactly where it came from can be a little bit of a problem. There's plenty of room, you may have to just rearrange. So the very first thing you'll need are some sorted wires. These are battery holders, and these are the batteries. Now, as with most of life, batteries are not included, so you'll have to get your own AA batteries. This is a little DC motor. I've added this little part here so when the motor is turning, you can see it in the video. So that's why that's there, and you can probably hear it turn. This is a little switch. Obviously what it does is when it's open, these two terminals are not connected, and when it's closed, they are connected. And this is actually a little holder for our bulb. You'll need at least the 3.8 volt bulb or a 5 volt bulb, and you can find that bulb value stamped right along the rim down here. It's very tiny. You may need to use a magnifying glass, but this is our 3.8 volt bulb, and we're only going to be applying 4.5, so that should not be a real issue. In addition, you'll need you can use the voltmeter that came with your kit, and take note that on this particular voltmeter, this is the common or the negative terminal, and you also have, and I've got to look at it, an embossed 3 volt and a 15 volt scale. So it's got two different scales. On this particular meter, the bottom scale is 3 volts and the top scale is 15 volts. And your meter could be different as they change addition, so always make sure you check the embossed values on your meter. And last but not least, you'll need your digital multimeter, and I've got a very fancy one. Yours does not have to be this fancy. It does need to be capable of measuring voltage, current, and resistance. For this purpose, we're only going to be using the voltage aspect of it. So DC batteries, by the very fact that they're DC, have a polarity. And most of the time you can find it stamped on there. This shows the positive, and the positive is always the little nub, the little part that's smaller at the top, whereas the negative is just solid flat. And you'll want to make sure you observe that polarity. My nub is my positive, my red should be my positive here. So I'm going to do that times 3 here. And what I find is easier most of the time when you're used to sticking batteries in, you put one end in and then the other. On these, it looks like it's easier to kind of do both of them at the same time. That one went in the other way, but that's fine. But when we connect our batteries in series, and what I mean by that, these are 1.5 volt batteries here, and we can make a 4.5 volt battery just by connecting them in series, the positive of this one to the negative of that, the positive of this to the negative of that. If you've ever had a flashlight where you had to put batteries in it and had to put 2 or 3 batteries in it, those were generally probably in series to increase the voltage value. So we'll be going positive and negative. Now I could take wire and I could join this positive to this negative and this positive to this negative, but these are designed to slide into each other. Now they don't slide in super easy, and I'm trying to keep this on camera so you can see, but they do slide in, and that just makes having less wires, which makes life a little easier, and they're making by these little contacts that's on the back side. So this meter, one of the things that you'll need to take note of is the 0 volt is right here. A lot of times it's on the end, or if it's got as much positive as negative, it'll be in the middle, but on this case it's about the quarter of the deflection of that meter. So we're sitting on 0 volts whether we're looking at 3 volt scale or the 15, but we're going to want to use the 15, which is the outer one on this meter, but again, your meter can change. You'll want to be sure that you look at that. So the first thing I'm going to do is make sure our source is outputting the 4.5 volts. So obviously I'm exceeding the 3 volt scale, so I'm going to have to use the 15 volt scale to measure this, and I'm going to slide our other materials just kind of to one side here for a moment. And I'm going to hook this to the positive terminal because this meter does have a polarity, and we can peg it backwards and actually damage our meter. So I want to make sure I'm putting my red to the positive side and my black to the negative side. And I'm going to kind of lightly touch it, and you can see the meter deflect. And what I'm doing there is I just want to make sure that it didn't exceed my meter span, or I could damage my meter. But you can see that when I touched it, it only went about halfway on the display. So we're good. And I'm not sure how well you'll be able to see this on the camera, but we're using the 15 volt scale, which is on the top, and we're almost at 5, which is what you'd expect, about 4.5 volts. So bottom line, our meter is doing what we want it to do. So what we're now going to do is I'm going to leave this meter connected. We'll use this one to make some voltage measurements in a minute. In fact, we'll go ahead right now and we'll see, and this is why I love digital meters. I'm going to measure that 4.5 volts that we're measuring with our analog meter. And there it is, 4.678. So we can see a lot more detail with this meter than we can this one, but this one's working just fine. So what I'm going to do now is I'm going to take, and we're going to hook in our switch. And remember, a switch is just something that opens and closes. Closed means that the contacts are touching. Open means that the contacts are not. And I'm going to hook that into here. So I'm bringing my positive out of my supply into my switch here. And then I'm going to come off of my switch, and it really doesn't matter if I use red or black. This is really still my positive side, so I'm going to use red. To me, that makes more sense, because the reason it's still my positive side is if I measure here to here, I'll still get a positive voltage, and you can try that yourself in a moment. Now I'm going to go to my load, which in this example is going to be our lamp. And when it gets to the load, that's where the positive will go into the filament, and then on the other side of this lamp will return back to our negative. So I'm going to go ahead and hook that in. I'm going to open my switch, and trying to get 2 of these under here can be a little bit of a challenge, but it's doable. So there we are. So I'm going to put this here. Now obviously our goal is to get this voltage from our source to enter into the switch and come out and go to our lamp. So let's see if we have accomplished that. And there we go, yes we have. Now I'm going to show you one measurement that I want you to make right here. I want you to make the measurement across the load. So I'm going to come across my load and make that measurement, and sometimes it might be easier to get it excuse me, on the outside here. So there we are, 4.3. Now the reason we're 4.3 volts is because we now have applied a load to this source, and it's bringing down our voltage just a little bit to a more operating voltage. So there we go. So that's one of the voltage measurements you're going to have to take. Now for this lab, the only picture I need is one of this lamp circuit working, but in that picture I need a clear tag with your name and your ID, student ID 9000 number, or you can use your badge. And the reason I do this is fairly obvious. Everyone could share the same picture, and I would have a hard time probably not proving that. I mean, I'd probably prove it pretty easily if it's exactly the same angle and laid out. But by having your badge or having your 9000, I know this is exclusively yours. And if every student has to do that, I can see their exclusive circuit. So take a picture right now with this circuit on, with your badge in it. That's the only picture you'll have to upload. Now there's more to the experiment, and we're going to ask you for a couple of readings, so make sure and jot those down. I'm not going to show you those readings. I'm going to put my meter where you can't see it, but I want you to measure the voltage across this switch with the switch open, and record that. So you can write lamp circuit switch open voltage. And then you can say lamp circuit switch open voltage at lamp, and measure the voltage at the lamp. Then I want you to close the switch, and I want you to measure this voltage, and I want you to measure this voltage, and I want you to record those. Now the next experiment is going to be hooking up your motor. So I'm going to open my switch, take out my lamp, reinstall my motor in the place of where my lamp was. And I'm going to ask you to make the same 4 measurements here. The voltage at the switch with it open, the voltage at the switch with it closed, the voltage at the motor with the switch open, the voltage at the motor with the switch closed. And it may not be in that same order, so please make sure you take note of whether we're asking you to measure the voltage at the switch with the switch open, the voltage at the switch with the switch closed, the voltage at the motor with the switch open, and the voltage at the motor with the switch closed. And at this point, I don't know if you can see the little holes, but you should see some motion when I close the switch, and you could actually kind of see the pedestal it's mounted on torque a little bit when that motor starts. So we've got a working motor there. Now, as a bonus question, I'm going to ask you about a couple of the voltage measurements that you made there and why you think those measurements were what they are. And that's going to be for extra points, but the measurements you make both on the lamp and on the motor should be accurate should be exact to what we have, or at least we're going to give you some choices that you would have to pick that you know you've got the right one. So that's it for this lab. This is just kind of introducing you to circuits and how they work. And do be careful when you're using this kit. It's fairly robust to be $50, which are however much you paid at the bookstore, $75, whatever the case might be. But you do need to take care. It's not made to, it's not an industrial grade kit, obviously, but it is made to be used over and over again, and be very cautious with it. So treat it nicely, and it'll serve you well. All right, thank you.